Hello, I'm Stephen Gorard. I'm going to talking about conducting education research, and in this brief discussion, I'm going to outline how you could analyze one or two variables together. There are in the book, accompanying book, there are chapters looking at things like regression analysis, path analysis, qualitative comparative analysis, and others. Which I'm not going to deal with today. I'm just going to look at really quite basic stuff, which is really all you need to know. Most analyses are only required to be very simple. What I'm saying will be slightly different to what you might read elsewhere, because I don't draw a distinction between so-called qualitative and quantitative research. I think that the key distinction is between data which is in codes or categories, so whether it's sort of codes from themes from interviews or observations, or whether they're categorical answers to survey items or whatever, however you got them, and stuff which is numeric, genuinely numeric. By numeric, I mean that you can do arithmetic with them. You can add stuff together, you can divide them by 2 and so on. If you can't do that, then they're not real numbers, in which case they are categories or they're the other kind. I don't think we need to make anything more complicated than that. It's important to remember that the origin of the data does not affect how they're analysed. So it doesn't matter, for example, for a survey, whether it was done online, face-to-face, or by post or telephone, you still analyse it in the same way. Analysis, like almost all parts of research, is neutral as to the actual methods of data collection. Numbers, when you use them, are numbers of qualities. Numbers don't exist in isolation. They only make sense if they are representing the amount or the count or the measurements of qualities. And qualities are often, bundled together as frequencies. So even if you make a claim that a category or a code is unique, uniqueness is a numeric claim. The distinction between numbers and the rest is much less than people would imagine once you've cleared up a few nonsensical approaches to research, which I've talked about elsewhere. Whatever data you have, if it is possible to display it in a picture form in some way, it's useful both to you and to the reader, but particularly for you to see if there's any weird or wonderful results that have come your way, something that shouldn't be there, something that is impossible. So a graph, for example, of some figures is good, or a cross plot of 2 variables is useful. And then really what you're going to do, you can describe each data item individually. If you could say this person responded in this category to this question, or this person said this quotation or extended quotation in response to this prompt. But in order to analyze, we normally go beyond the unique or the individual to say there's a tendency or a difference or a pattern of some kind or a trend, so that you want to gather things in terms of frequencies to say, most people said this or a lot of people said the other, and to use examples to illustrate what they said or what they didn't say. But you can go, more than that and actually present frequencies instead of saying most or more or some, to say, 37 people reported something like this, or 32 people said this category in response to this question. And you can convert those to percentages, so percentages of those responding or those responding in a particular group. And that's a useful way because it's often easier to understand, that 50% of whatever is rather than 347 cases out of a 723. And you can cross-tabulate where you have more than one categorical or coded variable. You can then look at 2 or more of the categories. You might look at whether people living in the north responded differently to whether people living in the south to another question, which is also categorical, and that's called a cross-tabulation. These are simple approaches, the kind of thing that any primary school child could do if they might have done a tally chart or something, and that's really all what a cross-tabulation might look like. Nothing complex here at all. So that's categories. So really all you're going to do is present them as frequencies, probably convert them to percentages for usefulness, and you can compare two or more together in a cross tabulation. You can also add examples of each. So you could have a frequency count and then say, for example, X said this or Y said the other. Where you have numeric data, then it's traditionally presented as an average, the mean average, which is the total of all the scores for each case or the measurements for each case added together and then divided by the number of cases. So, for example, you might have the test scores for 100 students. So you would add together the test scores for all the students and then divide by 100, and that would give you the mean average score. And accompanying the mean would be the standard deviation, which is a measure of how spread out the cases tend to be. You get a sense of that from your graph anyway, but it gives you a nice standard measure of how far apart. So how far apart are the largest and the smallest, where are most of the data points clustered. The standard deviation, I'm not going to explain to you how to do it now. It's overly complex because of a mistake made 100 or so years ago that's made it weird compared to just finding the mean deviation. But again, all that's explained in the book if you want to do it. And of course, you can use calculators and computer software to find the standard deviation for you. But you would normally present the standard deviation with the mean. If you have two sets of numbers or two or more sets of numbers, then one possible way of looking at them together is to correlate them. So you would look to see if they present something like a linear relationship where as one goes up, the other one goes up, or as one goes up, the other one goes down. An example might be you plot the household income of students, so how much their parents earn, and the attainment they have at school in a maths test or something, and you discover that there's an approximate line, so that in general, the students with the highest income get higher results than the students with the lowest income. And you could use one value to read off the other. So you could, if I told you the income, you could have a good estimate of how well the child might do at school in a test. And if I give you the test result, you might have a good estimate of what the household income is for that child. And that would be what's called a correlation. The two things would be correlated. And in terms of just working with numbers or just working with categories, that's about all you'd need to know. In order to correlate them, you do need this linear approach. If they're not linear related, or not even closely, and you can't see a way in which you can make them linear related, then you'd have to do something like the frequencies and cross tabulations, even though they're numeric, because it doesn't meet an assumption for the correlation. If you can use correlation, then you can actually convert that into an effect size, so-called. What it means is it gives you a standardized difference, and that is the correlation squared. I won't explain why it's squared, but it is squared. And that tells you the proportion of the variation in one variable that you can explain from the other variable or predict from the other variable. So if this value was 1, it means you could perfectly predict, for example, how well a child would do at school from their household income. And if it was 0, it means that knowing their income would not help you to predict their attainment at school at all. And most real life values will be somewhere between 0 and 1. You can also have an effect size, which is explained in the book, called an odds ratio for cross tabulation. I'm not going to go into the details here, but you can work out a standardized picture of the table as an odds ratio. The third possible combination is you have one numeric variable and one categorical variable, and you want to compare or contrast the two. And the standard way of doing that is to compare the means. That is to say, for each response in the category, so each category, you'll find the mean of the scores for that category. So if you wanted to say, I'm going to divide my cases into boys and girls at school, then you would have a mean score for the boys and a mean score for the girls on, say, a test of physics, and you could compare the two. And that's simply a comparison of means. And those are your three approaches. With comparison of means, you can also convert to an effect size, and the standard way of doing that would be to find the difference between the means and divide them by the overall standard deviation. And that would tell you basically how many standard deviations the boys and the girls are apart from each other on average. But you don't need to do any of that. Just doing frequencies, cross-tabulation, mean, standard deviation, correlation if necessary, and comparison of means is basically all you'll need in your armory for doing any analysis for any research. Generally speaking, research is not made exciting by exciting and complicated analysis. Good research has good designs. So, for example, if you do a randomized controlled trial in which you're trying to find out whether a particular approach to teaching music is effective, you might have a large group, you randomly allocate them to one, half to one group which gets this new method of teaching music, and another half which gets the normal method of teaching music, and you then score them on the outcome measure. It might be their enjoyment of music or something, and you find the difference between them. And that's the answer to your research. The analysis is no more complex than that. It's the kind of thing that a 9-year-old or an 8-year-old can do in primary school. So you can do it, I can do it. And don't let anyone make you do anything more complicated unless you want to. Yes, it can be fun to play with toys and do regression and all that kind of stuff, but you don't need them for standard research. Anybody can use these kind of approaches. They're really, really basic. In the book, as I do look at a whole range of things, including stuff like sensitivity analysis and compliance analysis for things like interventions. But these are like decorations on the basic bread and butter stuff that you need. And the 3 things I've mentioned are all you need in your armory. Go away and try it.